This video is about fractions, equivalent, as well as adding and subtracting fractions. If we're going to be talking about fractions, then we need to know that fractions are always in relationship to a whole. So if this is going to be our whole, then in order to talk about fractions, we need to think about the equal parts we will divide it into. Let's consider dividing it into 3 equal parts. So I've divided my whole into 3 equal parts. If I take one portion of it, say this shaded portion, then I have represented 1/3. When I consider all of it together, then I'm looking at 3/3. So the top number is the number of pieces, and the bottom number, known as the denominator, is the number the whole is cut into. Here I have cut my whole into 4 equal pieces with this division line, this division line, and this division line. So I have over 4. The one with the lines dividing vertically has cut the whole into 3 equal pieces. So this would be a denominator of 3. If I colored 3 of the small 4 blocks, and so that's what I'm speaking about, then I would have 3/4. If, as I have represented on the right, I have just one of the blocks represented, then I would have the fraction 1/3. Here I have represented the fraction 1/3. I can create equivalent fractions by dividing the whole horizontally now, so along this direction. So now with this representation, I have cut the whole into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 whole pieces. So I'm going to rewrite this fraction representation then as over 12. And before I only had one colored piece, this whole thing, but now that's been cut into 1, 2, 3, 4 representations. So I will write that I have 4/12. So the fraction 1/3 is equal to the fraction 4/12. How can I convert 1/3 into equivalent fractions? Well, if I started with the smallest, most reduced form, the 1/3, then I can multiply on both sides by any number, both the top and the bottom. As long as I multiply by the same number, I will get an equivalent fraction. So in this case, I multiplied the top and the bottom by 4. I could make a different equivalent fraction to 1/3 by multiplying the top and the bottom by the value 5. Then I'll get the equivalent fraction 5/15. Now I want to add the fractions 3/4 and 1/3. I'll start by representing each fraction by a whole. So I have one whole that's been cut into 4 pieces, and I have 3 pieces highlighted. Also, I have another fraction which has the same size whole as the first one, but this time it's been cut into, with 2 slices, it's been cut into 1, 2, 3 pieces. And I've only got one piece that I'm considering. So if I'm adding 3/4 and 1/3, then I can't just add the 1, 2, 3, 4 highlighted things because they're different shapes. So here I have represented 3/4 plus 1/3. I'm going to change it so that we have equivalent fractions for each of these wholes, and they have the same size piece. So now I have made these lines, vertical lines down the first one, which was cut horizontally, and horizontal lines down the one that was originally cut vertically, so the lines are in the same place for each of the whole. And that's really cutting them into equal small pieces. So now, instead of the fraction 3/4, I've actually got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 portions of the whole, and I have 9 highlighted. So in other words, I've multiplied, because I have now multiplied by creating these 3 lines down each stick, I've multiplied the top and the bottom by 3, which gives me 9/12. I'm also going to do the same thing to the other fraction, and this time, because I'm adding horizontal lines, I've multiplied everything by 4. So I have, instead of 1/3, I have 4/12. Now that I have the same size pieces, we can see that we actually have the fraction 13/12. So I've used these little blue squares to indicate where they would have been here, 1, 2, 3, 4. And as I drag them down, I have the new blue squares filling in this bottom space, but there's one piece left. So that means I have 13, 12 and 1, 13 pieces of a whole cut into 12. So I have the fraction 13/12. I could also write this, since I have a whole, as the 1 whole plus 1/12. That would be the mixed number. Now I'd like to subtract 1/3 away from 3/4. So I see that 3/4 is larger than 1/3, so I should still have some pieces. But since the brown rectangle is not the same shape as the green rectangle, I can't just remove. Again, I will need to make equivalent pieces. So I have made the equivalent pieces by using the same method of division of each whole shape on the contrasting other shape. So now I have both horizontal and vertical lines on each of the shapes, so that means I have equivalent pieces to each of these rectangles. So that really means that I now have the fraction, instead of 3/4 minus 1/3, I have the fractions 3/4 times 3/3 and 1/3 times 4/4. So I actually have the fractions, this being 9/12 and this being 4/12. So I want to take these 4/12 away from here. Now, since they're the same size, I can sort of stroke out each one of these. So this one cancels with that one, this one cancels here, this one cancels here, and this one cancels here. That leaves me with 5 little pieces remaining. And if I subtract 4 from 9, then I should get the value 5. So since there are 5 of these little pieces and there's 12 in the whole, I have the fraction 5/12.